This video follows up the previous video that described the FN400 and LPC ERP components that are related to recognition memory. This video is going to dive a little bit deeper into the FN400. Okay, just in case you missed the previous video, first I want to define very quickly what an ERP is. It stands for Event Related Potential, and essentially we record the electroencephalogram, EEG, by recording from a number of electrodes across the scalp. So here you can see EEG, and time is the x-axis, voltage is the y-axis, and the lines represent activity on an individual electrode. We time lock the EEG to an event, like the presentation of a word or a picture, and then we average the EEG to reveal a signal. That signal is called the ERP. In research papers that present ERP data, even though recordings are taken from a number of electrodes across the scalp, they'll often plot representative electrodes. Like here you see P3 is presented in this research paper, and you can have x-axis is time, y-axis is voltage, and you see this particular ERP called the LPC is defined as 500 to 800 milliseconds. And for memory research, a lot of times we take the average activity across this interval and we compare it across conditions. So it would be the average activity for the hits compared to the average activity for the new or correct rejections. And then a lot of times we plot that difference, so we subtract the difference across the scalp in these scalp maps. So positive would be a redder color, so you can see the distribution of this particular ERP component across the scalp. Because the FN400 and LPC are related to recognition, I want to quickly talk about the basics of recognition memory. So recognition is seeing an item, and in the laboratory could be things that the experimenter presented to you, and then you're seeing them at test with a mixture of some new items, and you have to determine whether it's old, whether you previously encountered that item, or whether it's new. We can also have recognition memory in the real world, of course, if we see familiar people, objects, etc. Now, recognition can be supported by psychological concepts called familiarity, recollection, or a mix of both of those. Familiarity is a sense of oldness in the absence of remembering any specific details. And recollection is when you remember specific details of the original encounter. Like in the laboratory, we have people report on some of the contextual features that happened or that were associated with that item. We can also manipulate the degree to which you have familiarity-based or recollection-based recognition by changing the encoding processes. So this just refers to the processes that are happening when we first encounter the information, and they create the memory trace. And we could have weak encoding, where you're thinking about sort of the superficial details. In this case, you would have more familiarity-based recognition, or you could have strong encoding, where more information is bound in memory, and you have more recollection-based recognition. And just some of the ERP characteristics quickly. It's the FN400, so it happens right about 400 milliseconds. The time window that's typically used is 300 to 500 milliseconds, although this can vary a little bit. And it's called an FN because it's a mid-frontal. As you can sort of see, the distribution here is mid-frontal. And it's a negativity, meaning the negativity for unfamiliar items. So familiar items are going to have a more positive ERP. Unfamiliar items have a less positive or more negative ERP during this time window. Now, the FN400 has been associated with familiarity. I went into the evidence for that association in the previous video. The LPC, known as a late posterior component or the parietal old new effect, happens a little bit later, 500 to 800 milliseconds. Again, studied items are more positive than unstudied items. And this ERP component has a parietal distribution if it's words, can be a little bit more widespread if it's pictures or actions. And this ERP component is associated with recollection. So I mentioned in the previous slide that encoding can create recognition that is either more familiarity-based or more recollection-based. So if you think of these two concepts, familiarity and recollection, as two different memory signals, they could differ in their strength, right? So in this slide, I'm representing the memory signals, familiarity and recollection, by two different light bulbs. And when we have weak encoding, we're going to have more familiarity and less recollection. So this bulb is brighter than this bulb. And when you do that, and you look at the ERPs, you can have a situation where you have just the FN400 and no LPC. Now, similarly, you could have really strong encoding, and in that case, you would have a lot of recollection and less familiarity. And what can happen is you can have no FN400 and then a strong LPC. That happens in some studies. And in other cases, you have sort of a mix of familiarity and recollection, in which case you have both the FN400 or the LPC. So all of these conditions are possible, just depends on the individual stimuli, the encoding, all of those kinds of characteristics. So some concepts that are related to familiarity and the FN400, this concept of fluency. Fluency refers to the ease of processing. This is often used to create experiences of familiarity in the laboratory. Because remember, familiarity is a sense of oldness without any specific detail. So one of the ways that we can do this in the laboratory is to increase fluency, and you can create that sense of familiarity. So fluency is increased by perceptual fluency. So you could make the item easier to perceive. You could present blurry items and clear items, and the clear items are obviously easier to perceive. You could also do this by background contrast. So high contrast colors, easier to perceive than low contrast colors, for example. Another way you could do this is priming. So priming is when you present one item very briefly, usually sub-threshold, and then follow it by another item. And if you can generate evidence of carryover in memory here if you have faster responding or more old responses following this priming. There's different kinds of priming. So there's conceptual priming, that is when the first and the second item are related by meaning. So they're related by concepts. So for example, doctor, seeing the word doctor will make you faster to respond to nurse. And that's because they're related by meaning. Seeing the word doctor produces this conceptual fluency, or what's called conceptual fluency. The other way to prime things is by what's called repetition priming. This is where the first and the second item are the same thing, so you're repeating it. Now this would increase both perceptual and conceptual fluency. It increases perceptual fluency because it's physically identical to itself. And it produces conceptual fluency because it has the same meaning. It's the same item, so it has the same meaning. Now these things, prior exposure, perceptual fluency, priming, and conceptual fluency, produce this general concept called fluency. Now this model, the unexpected fluency model, comes from Mecklinger and Bader, Bader's paper, 2020 paper. I have a citation at the end of this video where they present a current model. I mentioned earlier that the evidence was suggesting that the FN400 was associated with familiarity. Well, this claim has been challenged. Voss, Paller, and colleagues challenged this claim because they collected data from many studies using some meaningless stimuli. And the meaningless stimuli didn't elicit the FN400. So only when items were familiar and had high meaning did they elicit the FN400. So on the basis of this and some other evidence, they suggested that the FN400 actually captured conceptual fluency or meaning that was being repeated from old or studied items. Keep in mind that most of the studies used stimuli that had meaning, like words or pictures and things like that. In fact, they even found idiosyncratic meaning could elicit the FN400. Now we're going to dive back into this concept a little bit later in the slides after we consider some other factors that influence the FN400. According to the Mecklinger and Bader model, they agree with Voss and Paller in the sense that conceptual fluency, conceptual knowledge can contribute to fluency, which can then influence the FN400. But keep in mind, they also think that there's other things that can influence fluency as well. So unlike Voss and Paller and colleagues, they're not saying the FN400 is only conceptual knowledge, but that it's one thing that can contribute to it. Now you'll notice in this model, two ERPs, the FN400, which is what we've been talking about, and this other ERP called the N400. Now there's a reason for that. They seem to be pretty similar, and they have some kind of association. So in this next slide sequence, we're going to talk about the question of, is the FN400 different from the N400? So Voss and Federmeyer noticed that the N400 which had been shown to reflect implicit semantic processes, was very similar to the FN400, which was showing influence from semantic or conceptual priming rather than familiarity. As we were just discussing, the meaning clearly was associated with greater FN400 amplitudes. So they wondered if they were the same ERP. So what they did in the study is they compared some semantic priming condition, ERPs, to a standard recognition condition. And what they found is they found the same topography for the ERPs in both conditions. And then on the basis of that evidence concluded that they are indeed the same ERP reflecting the same psychological process or implicit semantic processing. Now this claim was challenged by Bridger et al. What they did is they separated the two tests. They separated the semantic priming and the recognition, so they followed the same logic that Voss and Federmeyer did. But then they compared the ERP topography. And what they found is that the priming produced a more posterior N400, so you can see the circles here, and the recognition was a little bit more frontal, more mid-frontal FN400. And on the basis of this topographic dissociation, they concluded that they're different ERPs. They have different characteristics about them. This has been replicated in other studies, such as the Strozak et al. Paper. So this prompted Mecklinger and Bader to argue that the FN400 has a mid-frontal topography and captures differences in relative familiarity. So relative familiarity would be if you're studying items like words that have pre-existing meaning, but you study some words and some words are old, and then they're intermixed with some new words on the recognition test. The old words have a relative increase in familiarity because of their recent exposure. And so the FN400 is going to capture this sort of relative familiarity. The N400, on the other hand, captures differences in absolute familiarity. And absolute familiarity would be equivalent to or similar to pre-existing familiarity that comes about from things like semantic priming or conceptual fluency, so overlapping meaning would increase absolute familiarity. So the absolute familiarity would generate this N400. So similar, but not the same, probably capturing different aspects of underlying psychological processes of familiarity. Another thing the Mecklinger and Bader model says is that there are some top-down processes on the FN400. What this means is your knowledge can influence the FN400. Now, this could be knowledge that people bring to the remembering situation, or it could come from earlier experiences that now impact how you're remembering. So a couple studies demonstrate this relatively clearly. So the Lanish and Zish paper, what we did is we had people encode words using a shallow encoding test to create weak memories. Then at test, we presented the items either blurred, so this lowered the perceptual fluency, or clear, so unblurred version. Now what we did is we also did this in a different context. So in one version, the clarity, so whether the item was old or new, was randomized, of course, because it's a recognition test, but also whether the item was clear or blurry was randomized. And then in another condition, we blocked it, meaning they saw a block of old and new clear, followed by a block of old and new blurry, and vice versa. We counterbalanced that. And the key upshot of this is that in the random condition, we observed the FN400. So it was present in the random condition, but it was not present in the blocked condition. So this would suggest, remember, it's the same stimuli, same perceptual manipulation, just organized differently on those two different tests. And what this suggests is that there's some top-down influences from either blocking or randomizing those trial sequences that influence the emergence of the FN400. We followed up on this with a different kind of familiarity. So we manipulated pre-experimental familiarity by presenting people pictures of products that they had seen before, or we eliminated pre-experimental familiarity by showing them novel products, products they hadn't seen before. Now the key here is this novel products, these off-brand products. And one test, we called it the pure test. It was only where they had only these novel products, old and new intermixed. We did not see the FN400. We saw different ERP components, but we did not see the FN400. However, when we mixed in these novel products with products that had pre-experimental familiarity in this mixed test, we did see the FN400. So again, same stimuli, same encoding, same stimuli, different context creates a situation where you have the emergence of the FN400 in one condition and no FN400 in another condition. One of the things that I wanted to come back to was this idea that meaningless images don't elicit the FN400 that Voss and Paller demonstrated in multiple studies. We investigated this a little bit further with the understanding of these top-down influences on the FN400. So Linus, Batterman, and Aberman, what we did is we had people study meaningless abstract art, but then we manipulated the expectancies. So one of the things that people can have is top-down influences is expectancies about what the memory experiences are going to be like. So we manipulated that. So in a standard condition, participants were told that there was an equal number of old and new items. In the old expectancies, we told them there were more old items on the test than new items. And in the new expectancies, we told them there were more new items than old items. In reality, there was an equal proportion of old and new items on each one of these tests. The key result here is that for old items, for old items called old, FN400 increased with a change in expectancies. Here you see the ERP graph here. And if you look at the old versus the new, it generated this pretty prototypical FN400 difference from old items just by changing the expectancies. Compared to the Voss and Paller outcome, we think what these data show is that meaningless images don't generate an expectancy to have familiar experiences. They just are very difficult to remember, and so they don't create a context where people are expecting to have those kinds of experiences, and so they don't generate that FN400. If you do something to change their expectancies, like tell them they're going to have more old items on the test, all of a sudden that FN400 can appear and can be present. So it's not that the meaningless items don't elicit the FN400, or I should say can't elicit the FN400. It's that they don't because they don't create the right expectancy for retrieval. This is what we would call a key here in this model is people have to attribute their processing to the past, to memory. So again, Mecklinger and Bader talk a lot about this and how all of this works. So for more, this is just an intro video, but for more on this, I would refer you to the Mecklinger and Bader. They review all of the literature and present that model that was touched on in this video. I would also reference you to the Voss, Lucas, and Paller paper, as well as many of the other excellent papers that they have where they talk about and criticize some of the existing evidence and point out some of the weaknesses of some of the prior designs used to investigate ERPs, in particular the FN400. Then you can also look at our 2017 paper where we talk a lot about all of these things that we've talked about in this video and also present additional evidence of top-down influences on the FN400. The other thing I would encourage you to do is to take a look at the LPC video. I'll put a link at the end of this video. Thanks for watching.